Hello, my friends. Welcome to my another lecture about Internet Protocol set. In this lecture, I'll explain everything clearly to walk through our experience. The last time we learned another things, which is helper functions for how this Internet is distributed. Anyway, so we'll understand everything clearly. So just follow the steps, step by step. We'll learn how to programming, how to do these things, how to start to learn any programming language. It will help you to understand fundamental of these systems. Okay, you'll understand architecture of this system. Okay, well, the computer science for that very important to understand what you're programming or what you're doing exactly. The Internet Protocol Suite. Let's start. Let's come a little down. As we've seen over the course of this unit, there are many protocols that power the internet. Each protocol operates at the different layer building functionality on top of the layer below it. The layers of internet protocols are often visualized in a diagram like this. Like what? Okay, we have application layer, which is HTTP, which is the recent version will be HTTPS for the security. We'll learn all of them, but step by step we're going, okay? So HTTP, which is Hypertext Transfer Protocol, and TLC, it will help again for security when you send message across of you. DNS, which is domain name server. So domain name server, sorry. This is application layer, which is you'll see here HTTP in this point in the link, TLC in the message. So again in this point in DNS, so DNS or DNS you'll see for the site. I mean this domain name servers. And transport layer will be TCP, Transmission Control Protocol, and UDP, which is User Datagram Protocol. It will help for the transport side, which is check to be sure the message going across of you and coming back. There's some process for apply or for check if it is true communication between IP packets, and yeah, for security again, for send information clearly. And network layer will be IPv4 and IPv6, which is we learned already about that, right? Okay. The another one, link layer. Layer will be Ethernet and wireless LAN, which is radio signals, and Ethernet, which is with the cable at this point. Let's come down. I can little more, go up, little more, again, little bit more. Okay, that diagram is by no means complete. There are many more protocols in the Internet Protocol suite, especially at the application layer, such as SMTP for sending email and FTP for uploading files, which is their etc. It's more alternative. Let's review protocols at each layer and their contributions to the Internet. Layer by layer, what's turning on, what's going on there, right? At the bottom, at the bottom layer, two competing devices need a physical mechanism to send digital data to each other. They send electromagnetic signals either over a wired or wireless connection and interpret the signal as bits, right? The type of physical connections affects the bit rate and bandwidth, which is we learned already because we are just doing or summarizing to understand all things clearly. Right. I think you're in good point right now to understand everything what we did before, step by step we are passing off on them. Okay. Let's come down. We already demonstrated it here to understand. When you send here electromagnetic signals, it will be wired here, wired and wireless connection. So this interpret the signal as bits. So it will convert a bit here. So when you send here signals, it will be one. When you stop for signal side, it will be zero. Okay, let's come down. Okay, down. Once a network is bigger than two computers, we need addressing protocols, which is we need to uniquely identify who is sending data and who should receive the data. Every node on the internet is identified with an IP address. IP address like your identity number. Yeah, it will be like that. Just think you have identity, right? On identity you have number, password number, passport number. It's like that. On all computers, each computers have their own IP address, like their own ID numbers. Okay, this is one example here. IPv4, IPv4, IPv4. Their own ID numbers like IP. Okay, you can understand like that. There have some hierarchy between them. Anyway, the road between any two computers on the internet isn't just a straight path from A to B. The data must pass from router to router until it finally reaches the destination. Strategy that comes from the internet routing protocol, which is we already learned about internet routing protocol 2, how to go fast or how this going fast, how it's playing this game, okay, to bring this data to another one between sender and receiver. Okay, here we have IP address, one computer, it's sending the message and it's going from the routers to router, jumping here. It's going from this way to there and this and etc. It's coming here. This IP or this computer, their communication part, it's working like that with the routers is knowing best way to go there. There are some algorithms. Anyway, let's come down, let's look for the security side, what's happening there. Data needs to be broken up into small packets with which are then assembled at the destination. The transmission control protocol, which is TCP, the important one, then UDP, because UDP is very fast, but it's not checking all details. For that, we're using TCP. Generally, we're saying TCP IP. We're using at the same time IP TCP. They are together because TCP is more secretive or more honest than UDP. You can think like that. Okay, is used to ensure reliable transport of those packets with sequencing, acknowledgement, and retries, which is you're sending message the across of your computer. So sender sending message, a receiver tagging, a receiver saying, "Oh yeah, I got this message. Yes, it's here." Then it's gives his information. Another computer like, "I got it. Yeah, I'm sure about that. Let's get it." And we calling it like this process, like sequencing will be there will be numbers. Anyway, I told you before, acknowledgement will be the communication part. Like I got it. Yes, I did that. I got. Yeah, I got it. Yeah. So they are understanding. We calling it like that. And a faster but less reliable transport protocol is the user datagram protocol UDP. I told you, which is I can show you like that. Sequence will be here, our message here, like that. Okay, the message side, data side, and acknowledgement will be here, the message going, and it's saying, yes, I got this message, gives information another computer, hey, I got it like that. Let's come here, down, let's go a little bit, tiny bit up. There are many uses for the data flowing around the internet, such as sending mails, uploading files, or chatting online. The most common use of the internet is the World Wide Web. This is not internet, Okay, this is World Wide Web, part of the internet, not entirely internet, part of internet. Okay, just don't think like if there is no World Wide Web, then internet will not work. It's not that. Okay, this is another protocol. Okay, World Wide Web with its millions of publicly viewable websites are made possible due to the hypertext transfer protocol. Okay, we can maybe I can show you from here. Okay, this HTTPS. Don't see this point. HTTP is hypertext transfer protocol, which is staying here like bridge, like bridge. I think. Yeah, if I'm right. Okay, the this one World Wide Web here, it's creating starting point, but we can put also age or anything to indicate. Okay, but generally we're using World Wide Web because this is most of use for about most of use uses. HTTP also here I told you for communicate with the HTML or to get for programming side. We can visit the website by typing a domain name in the browser address bar since the browser knows how to turn the domain into an IP address. Okay, I told you IP normally for human readable we doing it like domain name system. We're saying domain, which is here Figma. This Figma normally looking like some numbers, which is we calling IP packets. So in IP packets, it will be IP address. Sorry, not IP packets. It's normally like some numbers, okay, like that. But for human readable, we visualizing it like that, okay, with the GPU. I mean, okay, we're demonstrating it like that. You can think normally this is looking back of this computer, back of the operating system. It's different in kernel or which is yeah, in the back end side, it will look like IP packets, IP address, sorry. But if you look like human readable or user interface, you'll see Figma like human readable. Okay, let's come down. Okay, this is one example for it. Let's check it. HTTP, which is our hypertext transfer protocol here for speak to between so speak to it let's say HTML files. HTML also helping process here. Anyway, and we can get information from this side with the fetch or get or like send. Anyway, we can use something there. Okay, first you sending the right side data size like that, and it's saying yeah this is true, this is our programming point. You can think like this is we are in Visual Studio Code and we our codes here and it's codes speaking with this side user interface. Anyway, it's that. When the data contains private information, it needs to be transported securely from the sender to destination. The Transport Layer Security (TLC) protocol uses algorithms to encrypt the data while certificate authorities help users trust the encryption. What we're saying here for secure for your information for security we're using Transport Layer Security (TLC). It's helping to it's helping to make your message secret or in security, in protection. Okay, this is our user, like me. The client will be computer or any Android devices, or laptop, anything. This and this is our certificate authority which is we saying TLC side, Transport Layer Security side. this point, our key here, so to represent or recognize the security part. And this point is the server, which is we taking information from there. It can be any like thing you writing some program with the Python or C++, or inform, or just think like you're in HTML, you're writing something there, and the information is going there anyway. It's that, and with the security way. A protocol stack. Yeah, we have protocol stack. When a message is sent through the internet, it doesn't use every protocol in the suite. It does use at least one protocol from every layer. However, when you're loading a web page from a domain your browser has now visited before, your browser may need to make a DNS request, which is domain name site, like I showed you before. It's going step by step with what our internet provider IPS. I think I forget it, but yeah, the request is sent through the internet. Like what? Like that. Look. Now, in this point, in this case, application layer will be domain name server, transport layer will be UDP, which is user datagram protocol, which is fast but not secretive, not too much secretive. And network layer will be IP, and link layer will be wireless LAN. Just think like in wireless, first things going the radio signals, and it's going in IP which is looking like IP address, and UDP checking this IP address between two computers or devices, and DNS domain name servers. In this point, it's checking all domain name address here, domain name server, which is in that point this IP converting a DNS like the human readable point. Then your browser will make an HTTP request to fetch the web page. This protocol stack is used when an HTTP request is sent through the internet. Okay. In the HTTP request side, we will bring data to our front of front of eyes. So from user interface, which is HTTP side, will be we will say like get HTTP dot something like anyway http dot request that get anything from any point. Then okay, application layer will be here, that transport layer will be TCP, which is better than UDP in some point, generally like that. It's not fast maybe like the UDP, but transmission control protocol will be very helpful for security or for safe for data. I mean, network layer will be IP here, and link layer will be wireless LAN again in this scenario. Okay, it's going like that. IP, TCP working in IP, TCP IP, and HTTP will bring information. We will request. If the web page is served or HTTPS, then the stack includes multiple protocols at the application layer, both HTTP and TLC, transport layer security, which is I told you we demonstrated their K. It means security. Here in this situation, our HTTP, which is for request, again, hypertext transfer protocol for bring our information from server side. The server from server side information will come slowly, and TLC will check like transport layer security will put their security side security things, and it will go with the TCP with the details for check within two devices. And again, we have IP side in network layer, and link layer will be again wireless LAN, like local area network. Okay. If you remember, the wide area network also have LAN, WAN, and another. Okay, let's look for practice questions. understand better what we did. This is very good. Let's take pencil. Okay, which of the statements about Internet Protocol IP are true? Which of these statements? Okay, the first one, it is the only protocol used in Internet communications. It is the only protocol used in Internet communications. Do you think it's true? It is the only protocol used in Internet communications, IP. Do you think it's like that? Another one, it is used every time a competing device sends a message over the internet. It is one of many protocols used on the internet. What do you think? Now you can check it. You can pause video and you can answer it. What do you think? Okay, I'll give answer. I cannot wait. I'm so exciting to wait. So I'm not. I'm so exciting to give answer. Okay, it is the only protocol used in internet communications. No, not only this protocol we using in internet communications. Many more protocols we use it in internet communication. This is one of them, not entirely that. It is used every time a computing device sends a message over the internet. Of course, that's true. It is because every device have their own IP address. It is one of many protocols used on the internet. It is one of many protocols used on the internet. That's true. Our answer is E. Okay, our first question is true. You can check it if you want. The second question. Which of this is a way that the Internet Protocol IP contributes to Internet communications? Which of this is a way that the Internet Protocol IP, which is IP, contributes to Internet communications? It describes a mechanism for connecting two competing devices with fiber optic cable. No, sometimes with the normal cable or wireless. Yeah, some way, not that. It describes a method for mapping a domain name to an IP address. What do you think? It describes a method for mapping a domain name to an IP address. I think IP address to a domain name would be true. It describes a way to uniquely identify competing devices that are connected to the internet so that messages can be sent to them. That's true answer. It describes a way to uniquely, this is our K point, identify the competing devices that are connected to the internet. With this way uniquely identify, messages can be sent to them. When they unique and identify with this way, then they can send to message to each other. It describes a method for authenticating a user on a website. It's not that. Yep. Let's come down. Another question. I will be little. Okay, like that. How many protocols are used when a message is sent over the internet? How many protocols? This is a good question. Messages sent over the internet. No protocols need to be followed in order to send a message over the internet. The protocols are only necessary for additional functionalities such as encryption. No, not that. At least one protocol is used when the device sends a message over the internet. The device can also use the other protocols if necessary, but most of the time, oh, no, no, do that. One protocol is sufficient. No. Okay. Multiple protocols are used when a message is sent over the internet. The computer uses the stack of protocols that are most fitting of the type of message. Okay, IP, TCP, UDP, and let's go other TLC, and then wireless and many more things working role in this game. So the multiple protocols here, the key point, stack of protocols, also the key point fitting for the type of message. That's true. HTTP and World Wide Web, everyone playing the good good role on this process. I mean, yeah. This one is true answer. But let's check D because we don't have another answer, but let's check what it's saying. Only one protocol is used when a message is sent over the internet. The computer picks the most appropriate protocol for the type of a message being sent. No, that's not true. Okay, our question is our answer is C. This is the correct answer. This is all about this lesson. You learned many more things with me about this lesson. Next lesson will be open protocol, I think. Yeah, open protocol development, I think. Yeah. The internet protocol suite, I told you this is or this lecture you learned about these guys HTTP, TLC, DNS, TCP, UDP, so which is application side, HTTP, TLC, DNS, transport side, transport layer side, TCP, UDP, network layer side, IPv4, IPv6, Ethernet, IPv6, link layer, and Ethernet, wireless LAN, fiber cable, everything can be there, okay? Okay, this is more for this lecture. Thank you so much for joining. I hope you are exciting to waiting next lecture. I want to see you there. Have a good day. I hope it will affect you good for conveniently and efficiently to improve yourself for both this side of the technology or computer science. Yeah, you'll be very strong. Believe me, in the future. Just follow these steps and you'll understand everything clearly. Okay. Thank you so much for joining. Have a good time. I appreciate you to see you there. Thank you.